Hello everyone, welcome back to one more video. So as you can see in this video, I have already prepared my table, and so before proceeding with this video, let me give you a brief introduction on what devices I have kept and what is the purpose. So as you see this one, so this is a generic multimeter that we already have. So as you guys know, multimeter is very useful for electronic geeks. So you can measure the resistance stem, like the current, the voltage, etc. Here we have a signal generator. So it is very simple, 0 to 10 volt signal generator. Here we can provide the external power that I have provided using two batteries. So I have kept it in series. So that means I am supplying 3 volts power, and there is a knob over here. If I rotate the knob, the voltage will increase, and if I rotate the knob left, the voltage will decrease. Here you see we have two probes. So if I just show you, so the output or the signal which is generated from this particular device is exiting from these two terminals. What I have done is I've attached these two terminals, the positive and the negative, to the multimeter, so that you get to see the voltage which is being generated using this device. And this particular device we have made, this device is nothing but a millivolt meter. So what is the purpose of this device is there was a requirement told, we need to measure 1999 volts, so which is equivalent to 1.9 volts, so 1999 millivolts. So this particular device we have prepared, and the operating of this device is done using a 9 volt battery. So if I just show you, you simply need to plug this out. So we have this 9 volt battery embedded into this device. You can simply close the cover. There is a on off switch. As soon as I power it on, you see the display will start coming, and as soon as I power it off, the display will be off. As we have two terminals in the multimeter, similarly we have given two probes and terminals over here. So you see it is the signal input, the positive as well as the negative. And if I give you a close look, so then you can see we have given the specifications over here: the input voltage range, over voltage protection, input impedance, sample rate, accuracy, power source. And this device is so accurate that it will provide you zero output or the zero reading for zero voltage input. So this is the device. Again, I'll plug this in. So I've connected the positive with positive and the negative with negative. Similarly, I'll just give the parallel supply of the multimeter to this one, so that both the readings come similar. Let me just open up the wire. As you can see, I have this red probe, so I'll just plug the crocodile clip into this one, and I'll plug the black crocodile clip to this one. So if you can see, both the clips are present over there, and now I have both the devices running in parallel. So that means the supply or the wires, the signals is going to both the devices in parallel. So that means the reading to be shown over here must match the reading over here, and this device we have already calibrated, so nothing to worry about. So the readings would be pretty similar. So now let's begin testing. So what I'll first do is I set it to 2 volts. As you can see, I set it to DC, and then I'll power on this multimeter. So you see 0.05 volts. So now I'll power on this one. So as you see, 0.05. So now this is in a volt range. So you see this point appears, but this multimeter is in millivolts range, so the point doesn't appear. So now our next step will be, I'll simply rotate this knob and slowly increase the power or the signal voltage, and see how the changes are in sync with both the multimeters, one which we have made in our technologies and other which we have bought from the market. So I have this screwdriver with me, so I'll simply rotate slowly this knob. So if I rotate it towards right, you see it says it will increase, and if I rotate it towards left, it will decrease. So now let me slowly rotate it. You see, it's quite pretty accurate. Just a single millivolt is difference over there. If I increase it further and little bit, so as you see, the voltage is pretty accurate. So now let me increase it further. This is actually a 10-turn potentiometer, so very precisely I can vary the voltage. Now let's see, 352, 352. Let's increase it further, 676, 675. If I just make it equal, then also that's possible. You see, 674, 674. Let's increase it further. $994, $995. So as you know, like after 999, automatically 1.1, 1.2 such kind of voltage will appear, but in this device there will be no point and directly the millivolt will be shown. Let's increase it. You see, now it is 1.01 volt, but here it is showing 1002 millivolts. So which is same, just only it says 1 volt 2 millivolt and it one is saying 1002 millivolt. So both are same. So this particular device has been made on a custom requirement. So there was a requirement of my client who clearly told, like, I do not want to have any kind of a voltage scale. So they directly told me or instructed us that we only would read in millivolts. So you need not do calibration, or the display should directly display millivolts only. That is the reason we have designed this device. Let's increase it further. So you see, 1930, 1930, it's pretty accurate. Now let me do one thing, is like 1987, 1987. Now I'll slowly increase the voltage and just cross it above 1.99. Then let's see what happens. You see, this multimeter shows overload and this one shows 1. So as you can see over here, I have clearly written over range indication yes, and it will display 1. So automatically this will detect that the over voltage has been detected and automatically it will display 1. That means you are supplying more voltage to this multimeter and this multimeter can get damaged. So now let's do a second test. Let me do this voltage little bit less. So I made the voltage little bit less. So it's almost around 1749 or 1750. As you can see, both the multimeters. Now what I'll do, I'll just reverse the polarity. So this multimeter will show positive and this multimeter will show negative. That means I'll connect it the negative to the positive and positive to the negative. I'll just reverse the terminals, because here you see this device has automatic polarity indication as well. So automatically, as soon as I swap this one, automatically a minus symbol should appear over here. So you see, now I'll connect the negative to the positive and the positive to the negative. You see, automatically the minus symbol came and the readings are quite accurate. So this has an automatic polarity detection as well. So now again, let me switch it back. Yeah, that's it. So this is how this device has been made. Now the interesting part is, definitely I'll give you a close look on this device so that you get to know how this device is and like how we have made this device. So we build such kind of custom devices, and they are very good in quality and purely custom and tailored made devices these are. So any requirement that you feel in electronics, you may reach out to us. We can solve your purpose. Definitely we provide you consultancy as well. If you want the device to be manufactured by us, we provide those kind of services as well. Okay, so now let me disconnect all this apparatus and I'll show you a close look of this device, how we have built it. So let me turn off the power first. Now I'll disconnect the probes. So the probes are disconnected. Now I'll disconnect the multimeter probes as well. So the multimeter probes are also disconnected. I'll keep the multimeter aside. I'll keep my signal generator aside. So now we have this device with me. I'll just disconnect the probes. So now I am showing you a closer look of the probes or the wires that we have built. So as you see, at one end we have a crocodile clip. So as you see, this is we called crocodile clip. So this is a positive crocodile clip and this is a negative crocodile clip. And on the other end we have balloon connectors. So these are nothing but the probe connectors which gets inside the device. So this is the device that we have. This probe gets connected over here and this probe gets connected over here, and using this crocodile clip you can supply the voltage. So that's it. Now let me show you a close look of the device. So we have the device with us. So as you can see, so this is a purely an LCD display that we have provided. This is the battery connector that is present over there. This is the on off switch that you know I have given the demonstration. If you just plug this one out, then you can easily change the battery. It is very easy replaceable battery holder. You can simply disconnect the battery, again plug the battery and then cover it up. Very simple. We have provided the specification over here. As you can see, the input range, the input impedance, sampling rate, accuracy, power source, wattage, the automatic polarity indication, over range indication, the zero voltage for zero input, the model number, the manufacturing date, and it has been tested. Now let me show you the interesting part of this device. Is like, if I go to the back, you have a magnetic stand over here. So this is a magnetic stand and you can place it on table very easily. So like if you wish to have this a tabletop like this, then you can easily place it across. So I'll just show you a horizontal look so that you get a deeper understanding. So here's the device. I just open up the stand, place it like this. So you can use this device as a tabletop device as well. You see, so simple. And the best part is this is a magnetic holder. As soon as you press it, it will automatically stick. So no hassle, or like this will not create problems for you. So this is the device that we have built. Thanks for watching the video. Hope you liked it. So here are some of the pictures of the device that I have taken so that you get a deeper understanding of the look and feel how this device is built. Thanks for watching the video. Hope you liked it. Bye bye. See you soon in the next video.